All right, so yeah, thank you for coming right after lunch. So food coma's kicking in. Now is, well, now you're at this talk. So what we're going to talk about is full-text search in Couchbase. It's about maximizing your search experience. Hi, everyone. My name is Stephen Yen. I'm one of the co-founders here at Couchbase and have been here since the beginning. I've been on the technical side of things. So my co-president here.
Hey, I'm Abhinav. I work with Steve on the full-text team, in the full-text team at Couchbase. Yeah.
Yep. Very cool. So agenda-wise, what I'd like to talk about is a little bit of like, what is full-text search and a very high level of like, why would you use it? What is the philosophy behind it? And also get into what I call the secret of full-text search, the secret of FTS. We're also going to talk a little bit about what's new in 6.0 for Couchbase full-text search, but hopefully spend most of the time on a demo and tour of the system. So let's get right to it. So some of the questions you might all have, or I've heard a lot, is like, hey, full-text search, why should I use this thing, this full-text search system over other things like nickel queries? And well, for search, like many of you are probably familiar with things like Google, where you just have a big old text box and you can type in whatever you want and hopefully the right stuff pops out. And you see this text box all over the place, right? Like e-commerce systems, or like, I don't know, you have some customer service representative like system where people have to type in customer names. And the stuff that you type in might be like sometimes right, sometimes wrong. There might be typos, misspellings, maybe there are grammar things going on. So, I mean, we're all familiar with these kind of things, but like in contrast, there are other things like here where you're clicking around on stuff. Like I'm interested in the built for power laptops or the gaming laptop. And when I click on those particular things using my mouse or like my finger, there's like a product category ID, right? Right behind, underneath that URL, there's like a product ID, or there's a user profile ID, an exact ID where like there's no mystery. You know exactly what you want to look up. And in those kind of cases, like a structured query, like a nickel query is the right thing to do, right? As opposed to like this free form text of who knows what the user is going to enter. So that's a quick philosophy. Let's jump into the secret of full-text search. How do these systems actually work underneath the hood? Like, well, a lot of times in your data, like in your documents, you have various fields, like you have your blog posts and titles and your descriptions of products, a bunch of words, right? Like that are part of your like comments in your documents and stuff, right? And the words could be all sorts of different things. Like, it could be misspelled, all sorts of stuff. One of the things you need to configure when you set up a full-text search index is what's called an analyzer. So these analyzers are usually language aware. So there's like a specific analyzer for like English and a different one for German, another one for Spanish. And once the input words, the actual words that you have from your documents and your fields goes into the analyzer, it gets converted into what's called a term. And the term isn't necessarily exactly equal to an English word that we're familiar with. You're not going to see it in the dictionary somewhere. For example, all these different actual words, beautiful, with different uppercasing and stuff, they all turn into things like beauty, right? That's the term underneath the hood. And it's the term that gets stored in the index. So when you actually search for a term like beauty, you can now find all the documents that actually had, that beauty as an original word in some field in some document. And one of the things about this, the way the indexing works is it only does this term search. So if you think of everything in this kind of model, then suddenly a lot of mystery goes away. One of the things about these actual words is they may actually not even be English. Like they could be HTTP URLs or email addresses or user IDs. And you could actually configure different kinds of analyzers. For example, if you use what we call the keyword analyzer, which is sort of like the no-op analyzer. It's an analyzer that does nothing. It just like spits its input out as output. So the terms are going to be exactly, for example, user-230. So if you look up user-230, you're going to find the documents related to that, right? One other thing about the term subsystem or indexing that's going on here, it doesn't do any range searches or stuff like that. It's all basically an exact term search. So you're looking at like an exact term like beauty. It's not looking up for all the things that start with like the letter B, right? In order to look for all the things that start with the letter B, you're going to have to find all the terms that start with the letter B and look for those individual terms in the index. Let's switch a little bit to, well, what's news in Couchbase 6.0 full-text search. And the news is this thing called Scorch. Many man-years of effort put into the Scorch engine. Lots of great things that we're super proud about. Like it's like 20%, 1/5 the size of the index as compared to before, and 2x faster indexing speed, 1.3x faster throughput on high frequency term search throughput, on and on and on. Lots of great numbers that we'll scroll down past the screen. We didn't put them all up there. How does it work underneath the hood? Well, there's basically a brand new optimized indexing encoding scheme where like document IDs are now converted into numbers and encoded in numbers in what's called a finite state transducer, which is a very nice hunk of finite state machine work. We also use roaring bitmap technology underneath the hood now, which allows us to get at like SIMD instructions like SSE2 and do direct bitmap to bitmap comparisons and stuff. So really leveraging a whole bunch of performance. Now, is everything like perfect, like gigantic font 20x, like 400x, like green font? Not necessarily. There are trade-offs. In order to get some of these wins, like there's basically a whole bunch of more, like you could think of it like as, well, like compression almost, like in that there's now trade-offs, and then in order to get the smaller size, there's a lot more work the CPU needs to do. There's more data structures that need to come into play, more memory, resource trade-offs, and such and such. So try it out for yourselves and see how it works for you. And would love to hear the stories of like, you guys using it in anger. So enough talk. Time for demo.
All right. So for the demo, I've spun off a couple of instances from the source code, and I'll be using a sample bucket that Couchbase offers. It's called the travel sample, which essentially contains documents of related to travel, right? An aggregate of, say, airlines, airports, landmarks, and hotels and such. To start off with, let's just go to the search tab and create an index.
Oh, can you increase the...
Here? Yeah.
Yep.
That better? Okay. So let's go select the travel sample. Now, as Steve mentioned, the new default going with Couchbase 6.0 is going to be Scorch. And if you're familiar with our FTS product, you'll see the old search engine still available as well. Let's leave all the settings default for now. Let's just go ahead and create it. Give it a couple seconds to finish. And while it's doing that, let's go take a look at how the stuff looks on disk. So is that font okay? No?
A little bit bigger.
Better?
It's after lunch, so you need more.
All right. Let's make it even better. Okay. So let's see. We have FTS. Let's see what's under here. Oops. Right. So as you can see, we've split your. Let me do that again. So we've split your index that I just created into 6 partitions, right? This is a number that's configurable, but by default it's 6. This is to allow parallel access to your index. Let's see if the index is completed. Yes, it has. And so what is the size? So it's about 265 MB, right?
Cool. Hey, that 265, that's kind of big, isn't it?
Yeah, that it is. So this was a default index, right? So the travel sample dataset is pretty small. And if your dataset is any larger than the travel sample, which it most definitely will be, your default index can get pretty large. So the key thing here is, or the most important thing here is to identify what your use case is, what you're trying to address, right? And I have a simple 2-step approach on how you can tune your index to make it appropriate or relevant to your use case, right? So the first approach is identify what type of documents in the bucket that are of importance to you. And the second step is what sections or what fields in that JSON document are what contain content that's relevant to you. Right. Let me before I jump in and change the index, let's pick an example. Now I have a travel bucket. So let's say hypothetically I'm traveling to France. I have my airlines and my hotels all taken care of. Now I'm interested in figuring out what landmarks I'd want to check out. Let's make it a little more specific. So I'm interested in Gothic landmarks. So all I want is like what the Gothic landmarks are in France. So let's just go take a look at the document structure and see if there's any information that we can leverage for this situation. So this is a sample landmark document. Now I'm interested in France, so good. So we can leverage this country, right? The country field right here. And before that, the first step was to identify what the type of this document is. Great, it carries a field called type right here. Okay, carries a field called type. So Gothic landmarks. Now landmark, we have the landmark, which is the type over here in France. So we have the country over here, and Gothic. Any field that carries Gothic? Okay, great. So there is Gothic right here in content. So to start with, let's leverage these two fields and the type, right? Let's go back to search. Now let's edit this index. So I'm going to disable the default type mapping. I'm going to get specific with my type mapping, right? So I want documents of the type landmark. Let's just do this for a start, not do anything else, and see if there's any change in our index size and stuff, right? And the time it takes to build. This should be a whole lot faster than before. Done. So we have our 6 partitions, and if you look at the size of the index, it's down to 22 MB now. Now that's all the way from 264 MB, if you remember that. But we can make this index a lot more specific. So let's go ahead and create a child field. Now we're the two fields that we decided on were country and content, right? So I'm going to select field country and another child field content. I'll just leave all these the options checked in. I'll explain them in a second. We'll update the index. Now this should take a brief second as well. Oh wait, I forgot one thing. Now since I've added child fields, what I could go ahead and do is index just those specific fields, because we don't need the other fields for our search at this moment. This will be a brief second again. Clear. So now the new size of the index is 8.5 MB. So with this index, I can quickly query and get results on like where the Gothic landmarks are in France based on the data set that I have. I have a curl request ready for that. So let's go ahead and see if that'll work. Is that big enough? So if you see the curl request, now it's a JSON request, right? So it's a conjunction query. I'm looking for the term France to appear in the field country and the term Gothic to appear in the field content. Now the index is already built over landmarks, so I don't need to specify the type here. Great, so I have 8 hits straight up. And this took, as it says, 230 microseconds. Now this is a pretty optimized query because the index is to address exactly this situation, right? Now you may have noticed that when I went ahead and created the index, the type mappings, I left some of these selected, right? In particular, I want to talk about include term vectors. Now what is that? We could go ahead and disable that to further reduce the size of the index, by the way, but I just left it on for now. But what it carries, or what it puts in the index extra, is the position of the search term within that field, right? Now how is this useful? This, in combination with that store option, which isn't checked, I'm going to just check it to demonstrate something. You could use this for highlighting, right? So let's just go ahead and leave that store selected. So what it does is, what store does is it saves the field, the entire field in the index as well. So my index size would have gone up by a bit now because I'm saving the content field section in the index as well. But this will help with highlighting now. So it would map the array information that the term vectors give on the stored field value to make it look something like this. So if I were to do France, great. So it highlights Gothic for me And this is achieved by including the term vectors, which is the position information of the search term, and storing the field values. Right, so essentially, everything boils down to a term search, right? So although it's a conjunction query, it has two term searches happening, and it conjuncts the results, and this is what we have. Now let's try and make this query a little more specific and see what happens, right? Now let's say I'm traveling only to Paris in France. So how do I do that? Now if you do remember it, let's just go back here and take a look at that document again. There's a section called city too. So let's change the query a bit and add that to one of our search parameters as well. I have something copied here, so I've just made a small change to that query I ran before. Now this, as you can see, has 3 term searches, one for France, one for Gothic, and one for Paris. If I go ahead and run it, it says there's 0 hits. Okay, so it says 0 hits. Why does it say 0 hits? Because the index is not really designed to handle this particular query, right? We designed the index to handle just the field content and country. So to handle this specific query, we have to change the type mapping to include the field city as well. So let's just go back to that, edit. And let's add another child field, this time city. Should be done rather quick. Is that it? Oh, it's both. It says 5 hits. It says 6 hits. There you go. So this is how you can optimize your FTS index for your to handle your use case. You have to get real specific with the type mappings. You have to understand your document structure and design your index based on that.
There you go. There you go indeed. So I had a question. I heard somewhere that Couchbase is able to handle scale out and somewhere. Just wondering if you are able to maybe demo that.
Yeah, for sure. So when I started off, I did mention that I spun off 2 instances, although I'm using just a single instance here. Let's try just adding a node here and see how the index distributes across the 2 nodes. So let's just go ahead and add another index. Now I'm not interested in any of the services but search, so I'll just deselect everything and add that node. Give me a second. Okay, it shows up, and then let's oops, not add some, sorry, rebound. Should be pretty quick. Okay. So this was one node. I'll just open up another tab here and go to the other node. So going back to the original node, if you look at here now, 6 partitions have come down to 3 partitions. So the other 3 partitions have been moved to this new node. So the other one, this one was N0, this one's N1. It's just from the source, so that's why the naming. So the other 3 partitions are here. So you can now have the capability to route your query to either of these nodes. Whichever node you target your query against takes the role of the coordinating node, and this node is essentially responsible for scattering the query requests to the other nodes in the cluster, gathering all the requests, putting them together, and then returning the response to the user. Does that answer your question?
Yeah, cool.
Cool.
Very nice.
There you go.
Apparently I have another question. Could you, so what you talked about there was a bit of the happy path in terms of adding another node. I'm wondering, what if something goes wrong though? What if, something fails?
Disaster recovery then. So before I jump right into disaster recovery, I want to highlight this one setting that we offer with an FTS index. Let me just go ahead and show you that. Index replicas. So this is again a numbered count of the number of copies of your like index partitions that FTS will maintain for you. Let's take an example of what it would do, right? Like let's say you set your replica count to 1. What it means is we maintain 1 copy of your like active index partition on a node other than where the active resides. Now, obviously, your cluster needs to support the number of replicas, as in if you have like just 1 node in your cluster, you obviously will not be able to handle replicas. Now, with the 2-node cluster that I have, if I were to select, say, index replicas of 2, it would obviously throw out that warning saying that you don't have enough service in your cluster to support that many number of replicas. The number of replicas that this server will be able to support is 1, however. But before I do this, let's just do something real quick. So let's say the user, one of your nodes in the cluster goes down, and the user identifies that the node has gone down and decides to fail over it, or maybe they have the auto failover feature enabled where like the node is detected to have gone down and this cluster automatically fails it over for you. So I'm gonna, it's not enabled here, so I'm just gonna go and fail over this node, right? Now, if I go to search and say I was just searching for Gothic again, it says it's a partial result set right now, that some of the p indexes are not available because the node that's gone down, its active partitions are not reachable at this moment. Now, how do you get over this situation? It's with replicas, right? So let's go back here. I'm just gonna undo this operation, rebalance it back. I'm gonna rebuild my index this time, say with index replicas 1. So what happens, what is at least expected to happen in a situation where I fail over one of the nodes is the replicas of the actives that are no longer reachable are immediately promoted to active status, meaning your index downtime is going to be minimalized by a lot, right? So let's go do the same thing again. So I'm gonna fail over this node right here. I'm gonna go to search. I'm gonna go do the same thing again. Gothic. We don't have partial results anymore because the replicas of the actives that have been failed over have been immediately promoted to active status. There's a disaster recovery for you.
Cool, very cool.
Yeah.
I also noticed that when you had like one of the 2 nodes down, right, it still answered the query so that you could get that partial result, just in case if you did want to serve up a result page to the end user.
Right.
Right. You know, some result better than nothing
Yeah.
is a philosophy there, I guess.
Yeah.
So that's pretty cool. Are there any more search options?
Yeah, there's like a lot of more settings and options available with FTS. We empowered the user a lot with like a lot of settings. There's a lot of different types of queries. They're all pretty well documented in the docs page on Couchbase. Whoops, I don't have internet, but I'm not connected to the internet. I mean, so we have different kinds of queries. We have like compound queries. So all through my demo, I was just doing basic conjunction queries with like 2 or 3 term searches. You can use you can deploy compound queries with combination of disjunctions, conjunctions. There's fuzzy queries. There's faceted queries. That aside. Some highlights that I could talk about are relevance, right? So when we actually, if you go ahead and look at this, these results are ordered in a certain fashion. And no matter how many times you run the query, this ordering is going to remain the exact same because we score these results, right? They're all ordered based on the score. And this score, is calculated based on the search terms TF-IDF. Now we also provide the power to the user to like tweak the score settings, and this can be done by boosting, where like the user may be interested in this particular search term appearing in field X more than field Y. He or she wants to give more weight to field X than field Y. They can be they're able to do that as well.
If the term appears in the title field, it would be more important than maybe in the comments field or something, right?
So you could like put weight on which field matters more to you that way. And we have faceting too. Now, faceting essentially shows like other information about how many documents fit the search criteria along with the hits. Just a quick example. I'll just before I finish, it's a real quick example, right? So I'm just going to show you how you can do facets. So I'm just going to copy that and explain this. Okay, it's already clear. So shit. 1 second. Right. Was it this? No. Oop. There. That. So my original query for getting all the Gothic landmarks in France, to that query, I've added this new section right at the very end, where I just want to like distribute see what the distributed result is of what cities carry how many landmarks, and that's what facets are, right? So if I look at that, it tells me that there's 6 Gothic landmarks in France, which you already saw before, and there's 2 others in Lyon. So that's to demonstrate facets. I guess we're out of time. So.
Abhinav, Steve, very good. You covered a lot of ground in a very short time. Yeah. Thank you very much. Thank you for your attention.
Yeah. If you guys have any questions, we'll be at the Connect Expert bar, so please feel free to come and
the Connect Expert bar,
yeah.
For sure. If you have questions after the show, you can always connect with any of us or our other colleagues in the community on community.couchbase.com.